Hey guys, so this is your multiple choice station of annotating virus questions. So up here you have all the words, like the main words and their annotations, and then how we break down a question. The first thing I need you to do is correct the actual question on your paper. I definitely messed up big time when I made this. So take a minute, make sure that your answers actually match this. So pause the video and do that. Once you have done that, we're going to start. Okay. I'm going to bracket my question. Which statement below, which is to the left, okay, correctly identifies the viral replication cycles shown to the left. Okay. All right. So there are two types of different viral replications cycles. There's the lytic and the lysogenic cycle. Okay. Viruses are not alive, so they cannot reproduce on own. Okay. We're going to go over these two main cycles. We have the lytic and we have lysogenic. Okay. Lytic cycle, if I look up here, all right, it tells me that it lyses the cell. Lyse just means explode. So that means that it's going to burst the cell. And then this is also short. You see symptoms within like 1 to 4 days. Well, like within days. Within days. Okay. Lysogenic, this has the longer name. This is actually much longer. So this stays dormant or hidden. This is the really scary, sneaky one because you can have a virus for years and literally have no idea, but it's like quietly infecting your cells. Okay, so this is the long one. It has the longer name. It's the long one. This can be hidden for weeks, months, years even. Like HIV can go up to like 8 years and you have no idea that you have it. Weeks, months, years to see symptoms. But you could have it for like weeks, months, years. Craziness. Okay, so in each cycle, the lytic and the lysogenic, the virus attaches to a host cell. So this is the virus and this is the host. This is it attaching it, and then it injects its DNA or RNA. Okay, viruses have either DNA or RNA. Retroviruses have RNA. I'm going to put retroviruses. Retroviruses like HIV, they have RNA so that they would input their RNA into the host cell and then go from there. Okay. In lytic and lysogenic, the virus always attaches to the host because the virus cannot replicate on its own. It needs the host machinery. Within that, at some point, they will make copies of itself. Now remember, for the lytic cycle, the lytic one is the one that bursts the cell. Lysogenic does not burst the cell. It just simply incorporates its DNA into the host cells. Anytime that I see this image, which is lysing the cell, I'm literally like tearing open the cell membrane. I'm lysing or exploding the cell. This is going to tell me that this is the lytic cycle. Okay. So now I get to match what I've just annotated to my answer choices. It shows the lytic cycle because the cell is bursting. That seems correct to me. Bursting is lysing, same thing. It shows the lysogenic cycle. It does not show the lysogenic cycle. It shows the lytic cycle because the cell is not bursting. That is untrue. It's not B or C. It shows the lysogenic cycle. It is not the lysogenic cycle, so therefore my answer is A. All right, move on to number 2. Bracket, based on the data in the table to the right, why should you take all the antibiotic even when you see symptoms disappear after only a few days of treatment? Okay, antibiotics. Antibiotics target cell wall. Okay, the only thing to have a cell wall is bacteria. Viruses have no cell wall, therefore antibiotics don't treat viruses. So if you have the flu, don't take an antibiotic. It will literally do nothing. All right. Now, what does this table say? Let's say that you go to the doctor and they say that you have a bacterial infection. They're like, you need to take this antibiotic for 10 days. You are taking 200 milligrams of that antibiotic per day. You take it for 3 days. After 3 days, you're like, I feel better. I should just stop taking it. So then you stop taking it. That's with the 0. And then by the 8th day or the 9th day, you're like, I'm not feeling so great again. Let me start taking it again. So that's what's happening. Now look at the percent of pathogen survival. In this case, your pathogen is the bacterial infection. So it's the bacteria. Pathogens are really anything that cause disease. This could be a bacteria or a virus. In this case, it's a bacteria because we're treating it with an antibiotic, penicillin. This is how much of the bacteria is surviving. So I start with the most, 80%, and then as I'm taking the antibiotic, it's working because my number is decreasing, okay? Now I stop taking the antibiotic, and look, now it's increasing the amount of bacteria. Now, you notice here, I've started taking my antibiotic again, but nothing is happening to the bacteria. That is because the bacteria has become resistant. That is because it has mutated to adapt to medication. Okay, this is why when your doctor tells you need to take this medicine for the entire time, you need to take the medicine for the entire time. Otherwise, you're just going to keep getting sick. All right, now that I know all of this, I'm going to go annotate. Or I'm going to go figure out what this answer is. Another bacteria could infect you. Okay, very true. However, that's not at all related to my table. You are more susceptible. Susceptible literally just means likely to incubate. Incubate means grow. Resistant pathogens. We already know what resistant pathogens means because we annotated it here. This seems to be correct. I am growing resistant diseases in my body here. Okay, you are more likely or susceptible to be infected by other bacteria. That's like the same thing as A. It doesn't really have anything to do with the table. If you do not take all of the antibiotics, you will most likely die. Okay, 1, that's not what the table is saying, and 2, that's not always true. So bye-bye. My answer is B. All right, there's one more correction that I want you to make on number 4. So you're going to just keep annotating and working through this in the way that I annotated. Okay, for here, cross out cycle A, it's talking about the lytic cycle. Okay, and there you go. Get started annotating all of these fun things.